Welcome back. So we are going to continue here learning to use reference triangles. And something that's going to be really important for us to remember is the new way we defined our trig ratios. We said that sine of theta is y over r, cosine theta is x over r, and tangent theta is sine over cosine, or just y over x. See that? Y over x, sine over cosine. So for this first example, we're giving secant of negative 225 degrees. So we've got some stuff that we need to unpack here so we can solve this problem. I'm going to give myself a little more space in my quadrant 2. So first of all, where does that angle, negative 225, end up? So remember, we always start with a positive extending out on our positive x-axis, or this initial ray. And because it's a negative rotation, we're going to be going clockwise. So normally we say 0, 90, 180, 270, 360. But now we're going clockwise. Negative 90, negative 180, negative 270, negative 360. So negative 90, negative 180, negative 270, negative 360. So 225 is going to put us ending over here in quadrant 2. Okay, so now we need to create a reference triangle and determine what that reference angle will be. So creating a reference triangle, we always drop down or up to the x-axis. So here I have negative 225 degrees. What would my reference angle in that small acute right triangle be? So my reference angle, if we call that guy alpha, alpha is going to be 225 minus 180. Alpha is 45 degrees. So this little teeny angle in here, if I subtract or I add 180 to this 225, I get that positive angle 45 degrees. So what we're going to do is we're going to pull out this reference triangle. So I have 45 degrees. I'm asked to find secant of 45 degrees. Secant of negative 225 is going to be the same as secant of 45. However, we need to consider which quadrant we're going to be ending in. So remember, we said all students take calculus. S lets me know that sine is positive in quadrant 2. So what does that mean for secant? Secant is going to be some negative value in quadrant 2 because secant's reciprocal to cosine. Sine is positive, cosine and tangent will be negative in quadrant 2. Okay, so secant is the same as writing 1 over cosine of 45. And because we know our table, our 9 values for 30, 60, and 45, we know that cosine of 45 is root 2 over 2. So this is 1 over root 2 over 2. Simplifying that, dividing by that fraction, copy, change, flip, I have 2 over root 2, which rationalizes to 2 root 2 over 2, or just the square root of 2. So secant of 45, secant of 45 degrees, is equal to the square root of 2. But we are asked to find the secant of negative 225 degrees, and that's in quadrant 2. So we know it's going to be the same value, but I'm going to put this negative in here. It's going to be negative square root of 2. So we're starting to pull together a lot of information that we've been talking about so far. We redefined sine, cosine, tangent. We have this definition for which trig functions are positive and negative in specific quadrants. And then we're using a reference triangle because I know it's easy for me to find sine, cosine, tangent, or the reciprocal functions for 45. So I'm going to take the number for secant of 45 and just negate it, since negative 225 puts it in quadrant 2. Remember, a 45-degree angle would be in positive 1. All right, so let's try this again. Here we have sine of 1050. So we want to find the reference angle and the exact function value if it exists. 1050, that's a huge, huge value for an angle measure. But what I can do is I can take that 1050, I'll say 1050, I'll subtract 360 degrees from that. That gives me 690 is another coterminal angle. Subtract 360 again. That gives me 330. So 330 degrees is an angle in quadrant 4. I could also subtract 360 from it a third time. That gives me another coterminal angle of negative 30 degrees. So 1050, 690, 330, and negative 30 degrees. They all stop at the same spot. They're in quadrant 4. So even though if I were to draw 1050, I would rotate 1, 2, 3 times and get about right there. I don't want to draw it or think about it that way. I'm just going to go, okay, well, it's going to stop. And I have my negative 30-degree angle right here in quadrant 4. All students take calculus. Which function is going to be positive in quadrant 4? Cosine's positive. Also, its reciprocal function, secant, is positive. We're dealing with sine. So that lets me know that I know my answer has got to be negative. So this is the same. We're finding sine of negative 30 degrees. So what is sine of positive 30 degrees? And this is a value that I encouraged you, or actually I told you, I said you need to memorize it. And even if you can't memorize it, you need to be able to derive it quickly. But sine of 30 degrees is 1/2. So that means sine of negative 30 is going to be a 1/2, but is it positive or negative? And since we're in quadrant 4, sine is going to be negative. So sine of, I should say, negative 30 equals sine of 330 equals sine of 690 equals sine of 1050. These angles all stop right here, and since it's in quadrant 2, it's going to be equal to negative 1/2. So these are all equal to -1/2. Sine of 30 is in quadrant 1, so that's +1/2. That would be up there. But we're using what we know about sine of 30 degrees to infer what sine of -1050 is. All right, here we've got cotangent of -180. And this is a quadrantal angle. So as we previously said, the quadrantal angles, in building towards our unit circle logic, they're all on the edge of this circle of radius 1. So all those ordered pairs are going to be 1s and 0s. So where does cotangent -180 lie? -180 takes us over to the negative x-axis. So this is a -180-degree angle. It's coterminal with +180 degrees. They end in the same spot. So thinking about my point on this angle being a point on the outside of that circle of radius 1, what would the ordered pair be? And that ordered pair would be -1 for x and 0 for y. So tangent of 180 is y over x. Tangent of 180 is 0 over -1. Cotangent for 180 is x over y. So that's -1 over 0, which is undefined. We can say then that cotangent of -180 degrees is undefined. Let's do 2 more examples, and we're going to think about them a little bit differently. For this example, we're given a function value and a quadrant restriction. We know that sine of theta equals -0.4313, and theta is between 180 and 270, or that theta is in quadrant 3. What do we know about sine in quadrant 3? We know that tangent and cotangent are positive. The other 4 trig identities are going to be negative. So we know that sine of theta, it makes sense that we have this negative value here. Okay? So we know that sine is negative in quadrant 3. So for calculation purposes, we can ignore the negative. So let's think about this as a smaller angle. I'm going to say we have sine of alpha is positive 0.4313. If I was to solve for alpha, I would get that alpha equals sine inverse, remember we use an inverse operation, of 0.4313. So typing that directly into my calculator, I get that alpha, and make sure you're in degree mode, is 25.55008973. So this is an acute angle of roughly 25.5 degrees. But 25.5 degrees is in quadrant 1, and we know that this needs to be in quadrant 3. So 25.5 degrees in quadrant 3, this is giving us an acute angle alpha. There's where this 25.55 is coming into play. So what is the actual angle measure? Well, we need to add that 25.55 to 180 to find this theta value. So theta is 180 plus alpha. Theta is 180 plus 25.55. We determine that theta is 205.55 degrees. Now, you may have problems where we don't go through this process of ignoring the negative and it still works out. And we haven't learned everything we need to know about sine, cosine, and tangent inverse functions. So we have some properties that go along with that, and we will get to those. But for right now, we want to be thinking about determining that reference angle. And if we get an angle that doesn't make sense with our quadrants, we know we need to place that acute angle in the proper quadrant and then add what would be necessary. In this case, we needed to add 90 plus that 25. All right, so our last example in this video, we will work through this again. Here we're given the function value and quadrant restriction. We need to find theta. So we're dealing with secant theta is negative 1.0485, and we are in quadrant 2. So we're dealing with some angle that ends here in quadrant 2. But when we do our calculation, we're going to end up finding this acute angle. Maybe I'll call it beta. Right, so theta is this angle, and the calculator is going to give me some acute value beta. So whatever I get from beta, I'm going to need to subtract from 180. Which quadrant are we in? Quadrant 2. Again, we think all students take calculus. That means sine and cosecant, its reciprocal function, are positive. So secant, which is reciprocal to cosine, is negative in quadrant 2. So again, we ignore the negative, and I'm going to say, well, secant of beta is 1.0485. And I'm going to need to get this secant over here. That's going to mean secant inverse. But I don't have a secant inverse button on my calculator. So what I need to do with this secant is change it into cosine. So cosine beta, this is a reciprocal property. I get 1 over 1.0485. So beta is cosine inverse of 1 over 1.0485. Typing that into my calculator, I get that beta is roughly 17.49 degrees. Now that's not my final answer. That beta, 17.49, is a small acute reference angle. So theta, this measurement, which starts at, on the positive x-axis and rotates over here into quadrant 2, theta is going to be 180 minus that beta value. And if I do that subtraction, I end up with 162.51 degrees. So that's going to conclude this video, but we talked about beginning to use this kind of unit circle and using these reference angles inside reference triangles to help me figure out both angle measures and trig function values. All right, so we're building towards unit circle logic, which comes soon. In the following video after this, we're going to do an application problem.